Hello and welcome back. This is Jonathan Gardner. We're covering Python, the programming language. In this section, this tutorial, I'm going to cover how we can create new types in Python, or what we might call classes. And we talked about in previous videos about what a type actually is. We talked about how we use them. We talked about isInstance. We talked about the type function. I'm going to introduce to you a new way to use the type function to create new types, right? Just like we can use int, and we can pass in something like a string 8 or something like that, and then we're going to get an integer, right? Well, if you want to create a new type, like if you wanted to create something that's comparable to an int, something that, has its own behavior, its own methods and what it does, then we can actually use the type function. But when we call it with a single argument, we're going to find out what the type of that thing is. In this case, we're going to call it with 3 arguments. Okay, and the arguments, I'm going to call them name, bases, and dict. That's the dictionary, okay? And obviously, the name that you're going to pass in is the name of this new type, okay? Bases is something we're going to cover in the next video. It's called inheritance. It's a pretty important topic to understand how it works. And the dictionary is not really a dictionary. It's more of a namespace that this type will have. So it's the kind of the base set of attributes that this type has, including some of the functions that it does. And so if we were to do an example here, we might say something like my type is equal to type. And I encourage you to try this out in your interpreter and play around with it. So we're going to call it my type so we don't confuse ourselves. We're not going to have any bases, so we're going to do an empty tuple there. And then we're not going to have any attributes either, so we're just going to pass in an empty dictionary. Okay, and so we can instantiate a new instance of this type just by calling the myType function. And we'll see that when we say type of that O object, it's going to give us back basically, myType. Okay, and then if we say is O an instance of myType, and that's obviously going to say true. It is. What about is O, let's say is the number 8 an instance of myType? And that should be false, right? Okay. And that's how that works. And you can do things like with this object, you can assign attributes to it. So you could say OA is 5 and OB is some tuple, let's say 3, 4. Right? And we're assigning to the instance, okay? And we could also talk about things like when we assign to myType, right? We can assign attributes to the type as well, okay? And that gets into the namespace of the type. Just like with modules have namespaces, types have namespaces as well. Now, typically in Python, we'll call these classes. I find the type-class distinction is kind of arbitrary. When we talk about classes, we generally refer to things that we use the class statement to create. So those are generally user-defined types. But the behavior of classes really isn't that different from the built-in types. So I find it a kind of useless distinction. But I think from here on out, I'm going to call these classes. And the types will be sort of the built-in types. Okay. So we've talked about namespaces before, right? And in the case of types, we have the following namespaces that come into play. So we have the namespace of the instance, and that's like our O.A, right? In our example over here. We have the namespace of the type or the class. That's myType. It's also what we passed in as a third parameter when we called type to create the new type. Okay, and in the future, when we talk about inheritance, we're going to talk about where the namespaces of the inherited classes also comes into play. Okay, but I'm not going to cover that quite yet. Okay, when you do an attribute access, so when I say what is O.A, so if I go down here and say O.A, okay, it's first going to look at the instance. And if it's not defined at the instance level, then it's going to look at the type or the class. And if it's not defined there, then it's going to go through inheritance, which we'll talk about in a subsequent video. Okay, so to give an example of what I mean by this. So let's say we had my type.c is equal to 100. And then if I said, what is o.c, that's going to give me 100. Okay. Why did it give me 100? Because it looked first at the instance. It saw that there was no c defined in the instance's namespace or the instance's attributes. Okay. And so then it looked at the type or the class, and it saw that indeed there is c defined for that. Okay. Now, if I were to say o.c is now equal to 50, then when we say o.c, that will give us 50, but my type.c is left untouched. Okay, so that doesn't change. Okay, and you can play around with this. I encourage you to delete these attributes, add them in, and just play around to get a really good sense of how instances namespaces are different than the type namespaces, but they're linked together. So when I program Python, I never use the type with namebases and dict to declare a new type, except for in a special circumstance, which we're going to show you. It's called meta classes. It sounds really spooky and fun, and it is. Typically, we use the class statement, and this is the way the class statement works. So you start with the keyword class, then you have some name, okay, and then you're going to have parentheses, and you'll have the bases here, okay, and then you're going to have a suite. Okay, and the suite is pretty much just like the body of a function, right? It's code that gets run, except it gets run exactly once. Okay, and that suite is run in its own namespace, and that namespace becomes the attributes of the class. The attributes. Okay. And so here's an example. The basis is actually optional. So this part here is actually optional. You don't have to have the basis. Okay, let's go through an example. So we're going to create a class called greeter, and we're not going to specify basis. Okay, and so we're going to say the class greeter's greeting is equal to hello. Okay, and we're going to define this function. It takes one parameter called self, okay, and this is just going to print self.greeting. Pretty simple stuff. Okay, so when you see a class statement, the first thing you know is that this body gets executed. This suite of statements gets executed, and it's executed in its own namespace. Okay, and so in this case we have greeting, and we have say hello that's defined in this namespace, and these become the attributes of the greeter class. Okay, to give you an example of what I mean by that, we can actually go after this is run, and as you might expect, this is assigned to the greeter variable. It's a class with the name of greeter. So we can say greeter, I'm sorry, not greeting, greeter, that's say hello. And if we don't call it with any attributes, this is going to cause a type error because it expects self, right? So we're going to call greeter, say hello. What should we pass in? Well, let's actually pass in the class itself. And so what this is going to do is it's going to print hello. Because the thing that we passed in has a greeting attribute, self.greeting, that says hello, so it's going to print that hello. Pretty straightforward stuff, not very complicated. Okay. Now if we created an instance of the greeter class, something magical happens. So A is a greeter. Okay, and I'm gonna do it this way just to kind of confuse you a little bit, but to kind of really help you understand what's going on. We're gonna say m is equal to a.say hello. Okay, what I'm really doing right now is I'm kind of deprogramming some of the paradigms that you're used to in other object-oriented programming languages. I'm kind of teaching you what Python's actually doing. And in this case, m is now a method. If you look at the type of m, you'll see that it says this is a method, okay? What a method is it's basically this function bound to an instance of a class, in this case a, okay? So when you call that method, it's going to say hello. Why? Well, what it means by binding the method to this instance is when you call that method, the first parameter is always going to be that instance, A. And A is a greeter. A doesn't have its own greeting, so it falls back to the class itself. It sees that the greeting for the class is hello, and it prints hello. Now, if I were to say, over here, I'm going to say a.greeting is equal to hi. Okay. When I call m this time, it's going to print hi. Right? Okay. And why is that? Because the method is bound to the instance, so that self parameter is a, and a's greeting is hi, because we've set that in the a's namespace. It's not going to fall back to the class anymore. Okay. I know this is a little confusing, especially for people that are new to programming. This is something you just kind of have to get used to. Okay. Functions that are defined in the class's namespace, when they're accessed through an instance of that class, they become bound to that instance. And so when you call that, the first parameter is always going to be the instance itself. Okay? That's just something you have to get used to. Let's talk about a special method. So there's lots of special methods in Python. We're going to talk about probably the one you're going to use the most. In order to introduce this method, I'm going to give you an example. We'll continue with the greeter. So we have the greeter class. Okay. And then we're going to define a new function, underscore underscore init, I-N-I-T, underscore underscore. And it's going to take two parameters, self and a greeting. And it is going to set the greeting attribute of that first parameter, self, to be equal to the greeting that was passed in. And then you'll have down here the say hello method, which hasn't changed. And that's just going to print self's greeting. Okay. The init method is one of these magical methods, and you know it's magical because it has underscores around the name. Okay. Some people call it dunder. I just call it underscore underscore init underscore underscore to emphasize, hey, there's underscores here. Okay. So what happens is when we create a new instance of this greeter class, so when I say A is equal to greeter, okay, this is going to create a new instance of greeter that's fresh. There's no attribute set. It's just empty. Okay. And then it's going to call this init method with that new thing it just created and whatever parameters you supplied. So we have to specify a parameter. So we're going to specify hi. Okay. And so this new thing that we're creating is going to be self. Greeting is hi. And so that new thing's greeting attribute is going to be set to greeting. Okay. And so when I say a.sayHello, it is going to print hi. Okay. That's basically what's going on there. It's somewhat simple. Some people call this the constructor. I do not like calling it the constructor because there's another special method that kind of sort of is the actual constructor that has a very special behavior. Okay. Now, keep in mind this is a function just like any other function. We could have star args, double star, keyword args. We can specify defaults. We can do all kinds of crazy stuff, and we typically do crazy stuff there. Okay. Also keep in mind that just because we set the attribute inside of this init method doesn't mean you can't manipulate the attribute outside of it. All right. Last little note is I've been using this thing called self. Other languages might use something called this. Okay. In Python, we use self. That's just convention. Everybody uses self. I haven't seen code for a very long time that uses anything but self. Occasionally, when I'm feeling particularly sassy, I might use s. Okay, but then I'll go back and change it to self because it's kind of weird. Okay, and if you're wondering about these special methods, before we go deep into the special methods that exist, I wanted to share with you some of the special attributes of a class. So one special attribute is name, underscore underscore name. That tells you the name of the class. Another one is underscore underscore module, which gives you the module's name, not the actual module itself. And the last one that's kind of interesting is dict, underscore underscore dict. This gives you the dictionary of the namespace or the attributes of that the thing. Okay. After this, we have to learn about inheritance. We have to learn about the super function, which is super awesome. We get to learn about descriptors. We're going to learn about class methods, static methods, some properties. And we're going to learn about the special methods. And after we've covered all that, then I'm going to share with you guys how meta classes work. And meta classes are pretty awesome. They're used extensively in things like SQL Alchemy and libraries like that. Okay. And once you've covered all 5 of those subjects, and the previous subject on types and stuff, there's basically everything you need to know about Python objects and the object-oriented system, okay? And I'm going to try to present these obviously in a way that'll help you get the correct idea of what Python's actually doing and avoid a lot of the pitfalls of people coming from other languages or people that are new to programming so that you can actually understand what's really going on behind the scenes, okay? Before I leave you for today, however, I wanted to talk about why we do classes. Why do we have this mechanism? What good is it? It's so similar to modules. It's so similar to so many other things we have. Why do we have this? Well, as a general rule of thumb, I avoid classes whenever I can. Not because classes are bad, but because classes have a cost. There's a certain cost of introducing classes into your code base. And that cost shows up in terms of complexity, in terms of helping people understand how the code works and things like that. If everything's a function or an attribute in modules, that's pretty simple. But once you throw classes in there, it's like this other dimension you have to think about. Okay. So I'm going to go through and say these are situations where people typically use classes where they shouldn't. Okay. And one is a singleton. So if you know Java programmers, they're going to talk about singletons as if it's the bee's knees. Okay, a singleton is a class that is meant to only ever have one instance. Okay, and a good example of a singleton is none in Python, which is of the type none type. Okay, so there's no reason to have anything more than one none. Now the reason why they do singletons in Java is because Java is very weird in how it handles. There's no globals in Java, and so singletons become like a global, okay? So in Python, I would prefer instead that you did use globals and modules for singletons, okay? Another reason why people use classes sometimes is they want to build basically a library of functions, okay? And I see this all the time where they wrote a bunch of code and they have self as a parameter, but they never use self, okay? And so if you just have a bunch of functions you want to keep together, it's probably better to use a module. Okay, I find that modules behave like a class, right? You can take the module dot and the function name that you want, and it gives you the function. Modules are even better because you can actually import those functions into your namespace. Okay, and the other type of thing I see is people using it like a struct. Okay, a struct is a concept from C. And what a struct is, it's basically an object with no methods that only have attributes. And so what they're basically using it for is like a namespace. Okay. Typically, you can use a different data structure, like a list or a tuple or a dictionary or some combination to accomplish the same thing. And often it's better in terms of Python. The classes, they bring a little bit of baggage, a little bit of complexity that you don't need to have. If you just sit down and say, okay, this is the data structure, this is what this does, this is what that does, it's probably typically better exercise because you'll get a better understanding of what's actually happening behind the code. Okay, so these are reasons why not to use classes. So if you find yourself doing one of these 3 things, here's some alternatives you can consider. Okay, now that said, there are cases where classes are the obvious best solution. And of course, there's a whole lot of cases where it's kind of muddy. Either way is kind of okay. You know, classes seem to be what people like to talk about, so let's do classes, right? The first thing that I do when I'm writing my code is I start off trying to write a single file as a recipe. Okay, I just try to write, this is what I want the code to do. We might call this a script, okay? And what I find is that if you can do it as a script without writing a single function, do it, that's the best way to do it. But then you'll find that, hey, we need a function call, maybe 2 function calls. And if we added 3 or 4 more, then the code becomes a lot easier to read and understand. And so you start writing functions in your little script, right? And then you realize you have a lot of functions and you have other scripts and you want to share those functions between those scripts, and then you start writing modules, okay? Then you'll notice that in these functions, sometimes you're always passing the same data back and forth, okay? And you're like, you know, it'd be really convenient if we had like a namespace mechanism to access the data, okay? And that's when you start moving towards classes, Because once you start saying, like, we have this packet of data that always goes together, like for instance in 3D math, right? When you're doing graphical 3Ds, vectors, you have an XYZ. You always take the XYZ together. It always goes together. It never handles apart. Rarely do you ever consider X, Y, and Z independent of each other, right? And so as you're passing the XYZ to all these functions, you're like, I'm tired of writing attribute XYZ. Why don't I just have something that has XYZ in it that I can pass around? And that's when you start to use classes, okay? And that seems to be the ideal best case. When you have a bunch of data that you're passing around between functions that like to access that data and work on it, that's basically the paradigm for when you want classes. So that's pretty much my story of why you need classes. So I wanted to thank Tony Lee for being a supporter of my channel on Patreon. He's supporting at the $20 level, so I appreciate him for that, and all the other supporters I've had throughout the years. And if you go into my description, there should be a link, an Amazon affiliates link. If you click on that and buy things through Amazon, I'll get a couple dollars back. And the last thing to mention, of course, is I think the best way to grow this channel is by sharing this channel with your friends, getting more people to subscribe to watch the videos, and I think that'll help YouTube recommend this to the right people as well. So guys, I hope you enjoyed this video. We'll continue more with classes and subsequent lectures. Take care, have a great day, and bye-bye.